So the empirical rule we were able to use if our data are normal, or to tell if our data may be normally distributed. But if we don't know anything about the distribution of our data, or if perhaps they appear not to be normally distributed, they aren't symmetrical and falling within those percentage parameters set by the empirical rule, then we can still make some conclusions, draw some conclusions about how much of the data falls within so many standard deviations. And this is known as Chebychev's theorem. This says that the proportion of any distribution at all, no matter how skewed that distribution may look, the proportion of any distribution that lies within k standard deviations of the mean is at least 1 minus 1 over k squared, as long as k is a positive number greater than 1. So it won't hold for if k is equal to 1 within 1 standard deviation, but when we're talking about within 2 standard deviations or 3 standard deviations, we can apply Chebychev's theorem to any type of distribution. So in example 31, for a sample whose distribution may not be normal, what proportion of the data will fall within 2 standard deviations? So if k is 2, Chebychev's theorem says that the proportion that will fall within 2 standard deviations is 1 minus 1 over 2 squared. So 1 minus a quarter, which is 3/4, or 75%. (75% fall within 2 standard deviations. And of course, that is at least 75%. So it could be more, but we know it's not any less than 75% will fall within 2 standard deviations. Within 3 standard deviations, so if k is 3, Chebychev tells us that the proportion that falls within 3 standard deviations is at least 1 minus 1 over 3 squared. 1 minus 1/9 is 8/9. 8/9 of the data, or approximately 89%, fall within 3 standard deviations.